study the crucial elements of the aerodynamics in Formula 1. Controlling the drag and downforce of the car is a highly technical and painfully complex challenge, sometimes even a black art. The most important factor is the front wing, which creates a downward force, referred to as a negative lift, in order to push the front tyres much harder into the racetrack than simply the weight of the car alone. To demonstrate how the air flows around and over the bodywork, I'm going to use this as air. Now I need some assistance. Probably the most important element is the front wing. Let's take a closer look. It's made up of a main plane, which hangs from the nose. It's supported by a secondary flap. This slot gap and the angle of the flap determines the level of downforce, and it's adjustable during the Grand Prix using a simple tool. Even a small adjustment up or down makes a big difference to the level of downforce. On the end of the flap, there's a further gurney flap, a return angle, which helps generate the downforce. That's a low-pressure area just here behind the wing. As the air travels over, we get upwash and also a lot of very turbulent air coming off the side, and vortices tend to go inboard and disturb the air underneath the car. These side wing end fences have a big role to play in controlling that very turbulent air. Now the real challenge begins. The next section of the car comprises many elements which must work in unison to both control the wake and flow correct the upwash. Surprisingly, the top suspension arms begin the work, followed by the tongue of the undertray and then the barge boards, in order to send the flow down the side of the car. This creates a handshake of the air as it moves to the midsection. When it's all working well, the drivers have total blind faith and confidence that the car will stick despite arriving at 200 miles an hour, throwing the car in with the merest lift of the throttle. The direction change has incredible grip too. It's all further complicated as the front tyres and brake ducts turn through the airstream, creating further disturbance. Above the driver's head is the engineer intake, and it's important to present this area with high velocity, undisturbed air. Once inside the intake, further aero work is carried out to ensure that all 10 cylinders are fed good quality air. Air travelling through the side pod is mainly used to cool the water and oils. It's a push and suck system using chimneys to extract the hot and energised air. Along the side pods are many winglets, which create more downforce and manage the air back inboard. The rear of the car is all about managing drag and generating maximum downforce from the rear wing, and particularly the underbody. The upturn of the underfloor forces an expansion of the air and therefore a pressure drop, which in turn creates suction or downforce. The tunnels and the area just in front of the rear wheels is critical in order to enhance this suction and evacuate the air travelling under the car in a controlled and high-energy way. The rear wing package must help extract that air using the lower element and create downforce of its own from the flow passing over the car from the upper element. It's like an upside-down aeroplane wing forcing the car down. The side wing end fenders have to control the drag because we also need good straight-line speed, but it hurts the drivers following. So the air has been used and abused as it passes along the car, both for cooling and to generate downforce. It's then discarded in an angry mass directly into the path of the following driver for his car to handshake and manage. That's why it's so difficult to follow closely and to pass easily. With the complexities of today's Formula 1 cars, it's no wonder most of the teams are spending tens of millions of pounds creating new wind tunnels.